Now let's try to reverse the given singly linked list problem. So whatever it may be, when it comes to data structures and algorithms, one of the very much overhyped problem is reversing the given singly linked list. It is not difficult or whatsoever, just because of all the memes and all the jokes that you've been seeing on the social media. It kind of gives you a feeling that it is very much difficult to solve, but it is not at all difficult. Just try to follow the algorithm that I'm going to explain. You will never ever forget it. Okay, so that being said, let's just try to understand. You will be given an input list with some values in it. You have to reverse the given singly linked list and try to do it in the same place. That means that try to not use any additional memory in reversing process. Okay, so remember that here we will be given the head node of the singly linked list. Any node of the singly linked list will have the value as well as pointer to the next node, which is nothing but next. So that is the structure of the singly linked list node that we will be following as well. It will have value, it will have the reference of the next node in the variable name next. Now here, this is the input list that we have gotten. If at all, after reversing the given singly linked list, the output should be reversed. That means 1, 2, 3, 4, 5 are the values that we have in the singly linked list before reversing, and after reversing, obviously the output should be 5, 4, 3, 2, 1. Similarly here, these are the values in the input list and these are the values in the output list. And ultimately here, remember that input list might contain duplicates, or it might contain heterogeneous data or anything. The reason why I have mentioned this point inside the problem statement is that usually singly linked lists are usually most of the data structures are heterogeneous data structures, right? That means that they can hold any type of data in them. So that is the reason why here I have mentioned this. But nonetheless, even if your problem statement doesn't mention, you can obviously assume that singly linked list can have heterogeneous data, but it is completely up to the problem statement that I have defined here. Nothing to worry about that specific condition. And input list can be empty as well. Okay, so that is the problem statement that we have gotten. Now we need to write the effective logic for reversing the given singly linked list in place. Remember that here we have gotten a singly linked list head node. That means we can read the values that we have in every node of the singly linked list, and again we can construct the reverse singly linked list as well. But that is not the way we have to approach this problem, because the problem statement said that we have to do it in place. That means by just readjusting the nodes that we've gotten in the singly linked list, we should be able to reverse it in place. Okay, that is the problem statement. Now let's dive into how can we reverse it. Alright, so here the list that we have gotten has the values 1, 1, 2, 3, 4, 5. So if we represent it in the pictorial form of the singly linked list, this is how it is going to look. And here every node will have two variables in it. One is value and the other one is pointer to the next node in the variable next. Now we need to reverse it. For this, what we will do is we will define three variables. One is current node. In the beginning, it will be pointing to the head node that we have gotten, which is nothing but 1 that we will be getting in the function argument. Similarly, what we will do is we will define another variable called next node. This also in the beginning, it will be pointing to the head node as well. Along with that, we will define one variable called reversed list. This will hold the reference of the head node of the reversed singly linked list at any given point of time. Remember that this reversed list variable will basically hold the head node of the reversed linked list at till that point of time. In the beginning, there is no head node, right? That means that we haven't reversed anything. So here we will be initializing it with null. In most of the programming languages, we will initialize it with null. In Python specific implementation, we will be initializing it with none. Now what we will do is, as long as we have not reached the tail node, that means that whatever the current node that we have is not equal to end. How we will know? We will compare it with null. In Python, we compare it with none. So we will simply run a loop. What we will do? We will go on to the current node. So current node right now is not null, it is at 1. So what we will do is pick up the node that we are at, and this needs to be reversed, right? That means whatever the reverse list that we have so far, it will be pointing to the, it will have the reference of the head node of the reverse linked list till that point of time. So whatever the node that we pick up, it should come before, so that in the end we will have all the reversed values. So whatever the node that we pick up, what we will do, current node dot next that we have, we will be updating it with the reverse. So far it is having null, so it will have added 1 right now. Immediately we will have next nodes also, right? So we will update the next node with the current node dot next. It will be pointing to this one. Now also current node is not null, we still not have reached the end. What we will do, this is the reversed so far. So we will pick up 1 again, and 1 we will add in the front of the reversed list that we have so far. That means this current node dot next, which is 1 dot next, we will assign with reverse. As a result, the 1 will get added in the front, and the reverse list will be having this 1 in it. Immediately next is again having 2, we will pick it up, and 2, what we will do, current node dot next is equal to reversed. So this reversed will be having 1, we will add 2 here. Similarly we will move on to the node 3, and 3 will get added here. Immediately we will move on to the next node, we will add 4 here, and immediately we will move on to the next node 5, and we will add it here. Once we reach 5, current node dot next will become null, and we no longer have nodes to add. So here the final reversed linked list is nothing but 5 4 3 2 1 1. If you see 1 1 2 3 4 5 is what we have. If we reverse, 5 4 3 2 1 1 is what we have gotten. Remember that we will run the loop till we reach the very last node that we have. Basically the current node will become null or none. In the case of Python it will be none. In the case of any other programming language it will be null. So every time we pick up the node, this reversed list will have the head of the reversed linked list so far. So whatever the node that we pick up will get added in the front. That means the current node that we pick up dot next should be added with this reversed list so far. In the end, reversed we update with the current node that we are at. Okay, so that is the logic. Now let's try to do the same thing on one more singly linked list. Let's just say we have a singly linked list containing hi, bye, see you. So immediately we will start here, and this reverse list in the beginning, it will be null in most of the programming languages, none in the beginning. So we will pick up the node, and the head of the reverse list so far is null. So we pick up the node and we add the next to it. So hi dot next will be none anyway, and we will move on to the next. Okay, we will pick up by, this by will get added again, and then we will move on to the next node see you, and we will add it here. So see you by hi is the reversed list. We don't have any more nodes left here to pick up and process. Okay, very simple implementation. Just the point that you need to remember here is we will have 3 variables. Current node, it will point to the current node that we are processing. Next node is something that will help in keeping track of the next nodes that we can process, because current node dot next we are updating with reverse, right? So if we don't keep track of the next nodes in some variable, there is a chance that we might lose the track of that. That is the reason why we have here the next node variable. Okay, that being said, let's just quickly go ahead and write the pseudocode of it, and later let's try to write the programmatic implementation and validate various scenarios. Alright, now let's try to write the pseudocode. So here we will have one function called reverse singly linked list, and what it does, it will take the head node. Immediately, there is a chance that there is no node itself in the given head, right? So that means if the head node is equal to null or none, So this none check is for the Python specific learners and this null is for all other programming language specific learners. So here, if this is the case, we did not have a valid node reference inside this head. So immediately we can't reference it, we can't return, reverse it anyway. So we can return that null or none itself back to the user. If this is not the case, like I mentioned, what we will do, we will define three variables: current node, it will be pointing to the head. Similarly, we will define another variable called next node. It will be pointing to the head node itself in the beginning. Along with that, we will define one variable called reversed. This will hold the head of the reverse singly linked list till that point of time. In the end, that is what we need to return. Because if we have the access to the head node, using the next reference, we will be able to reach the end of the singly linked list as well. So here, in the beginning, it will be pointing to a empty value, which is nothing but null, or in the case of Python, it will be none. Now what we will do, as long as this current node that we have is not equal to null or none, in this case, what we will do, we still have some nodes to process. We need to pick up all those nodes and we need to construct a reverse singly linked list out of that. For that, immediately what we will do is, whatever the next nodes that we have, this will be current node dot next, right? So we will read and keep it in one variable. Now this reverse list has head reference of the reverse linked list till that point of time. Now it needs to get added on the next of the current node that we are processing. So current node dot next is equal to the reverse list. Now the head of the reverse list is nothing but whatever the current nodes that we are processing. Later on, whatever the node that we pick up, it should get added in front of that. That is the reason why here reverse we will update with the current node. That is done so far. Now the node that need to get processed in the later iteration is there inside this next node variable, but our loop is running on the reference of the current node. So we will simply update the current node with the next node so that it can run the next iteration. Once this is done, all the nodes that we get will get added on the reverse direction and we can simply return the reverse list reference itself, because it has the reference of the reverse linked list head node. That itself helps us in reading all the values, so we can return that. Okay, so that is the simplest implementation of the reversal of a singly linked list in place. So if we want to analyze the time complexity of this specific algorithm, obviously from very first node till the very last node we had to go. That is the reason why this while loop, whatever we have, will run for n number of times. As a result, the time complexity will be order of n. And the space complexity, if you see, we are not creating any list or whatsoever. With the simple couple of variables itself, we are constructing the reverse singly linked list in the same place. That is the reason why the memory consumed will also be constant, which is nothing but order of 1. Okay, so that is the pseudocode for the overhyped reversal of the singly linked list. Now let's quickly write the JavaScript code and validate the same thing as well. So if you observe here, since it is our first practice problem on singly linked list topic, what I have done is, inside the singly linked list folder, I have created a new file called practice. Inside that folder, I have created a reverse singly linked list. And in this file, basically I have created a new class as well as new function for reversing the singly linked list. One thing that you notice here is, since we are going to pass the head node of the singly linked list which we need to reverse, I have also imported the singly linked list class that we have implemented previously, so that we can reuse that here as well to construct the singly linked list object and pass the head node to the function that we are implementing, so that we can reverse the singly linked list. That is something that you need to notice here. All the imports are according to the structure what you see in the side navigation. If your folder structure is different, you just need to modify these imports and everything accordingly. Okay, now that is clear, right? Let's just deep dive into the implementation. So here, let me just remove this console.log, and after that, here, if you remember the explanation that I gave, what we will do, we will basically maintain couple of variables while reversing the singly linked list. One is nothing but current node, which basically holds the reference of the current node that we are processing. In the beginning, that value is nothing but entire head node. Okay, along with that, let's just define one more variable called next node. This will basically help us in holding the next nodes that we need to process in the iteration process that we will be writing in few minutes. In the beginning, this also I am going to initialize it with head. Even you can initialize it with null, that is also absolutely fine. Along with that, what I will do is I will define one variable called reversed. This will basically hold the head node of the entire reversed singly linked list at any given point. Remember, this reversed will basically hold the head node of the completely reversed singly linked list at any given point of time. Since at this point of time there are no reversed nodes, I am going to initialize it with null. Okay, now all we do is we will simply run a loop as long as this current node that we are processing is not equal to null. What we will do as part of the first step, we will keep track of the next nodes that we need to process. So here next nodes, whatever variable that we have defined, we will update it with current node dot next. Okay, so we have the access of the next nodes that we want to process inside this next node variable. Now remember, we need to reverse the singly linked list, right? And so far whatever singly linked list that we have reversed is available inside this reversed variable, and we have the current node also. Now to reverse this, what we need to do, whatever the current node next that we have, it should hold the reference of the reversed whatever we are maintaining here. So current node dot next is equal to reversed. Okay, so we have technically reversed till this point of time. Now the head node or the very first node of the entire reversed singly linked list is nothing but this current node. So what I will do is I will update the reversed to current node right now. Okay, so technically so far the entire reversed singly linked list head node is nothing but this current node, so I have updated the reverse to current node. Okay, now the current node that I need to process is nothing but whatever the next nodes that we had, which is available inside this next node variable. So here let's just update current node is equal to next node. Okay, so that's it. That is the simplest implementation for reversing a singly linked list. Okay, usually people say it is extremely difficult and all. It is not. You just need to remember the exact approach that you are following, so that you will be able to implement the solution very easily. Okay, once this while loop is completed, we would have processed each and every node that we have got inside the head node of the whatever the argument that we have been given, and the head node or the very first node of the reverse singly linked list is available inside this reversed, right? In the end, we need to return that reversed, so that we can process and print the values that we are getting inside the reversed singly linked list. Okay, so that is the exact implementation of reversing a singly linked list. Now if you see here, I have created a new object of singly linked list that we have already implemented, and along with that I have added 3 values into that singly linked list. This push operation, right? We have discussed, and we have added the implementation very thoroughly. If you want, you can check out what it exactly does is, it will basically go to last node whatever we have till that point of time, and it will keep adding values as we push more and more values onto the singly linked list. Along with that, here I have created the object of our class, and using that reference I have called the reversing of singly linked list function. To that I have passed the head node of the singly linked list. Okay, after that here this is exactly whatever the traversing logic that we have inside the singly linked list, right? I have written that traversing so that we can simply print and see what are the values that we are getting after reversing of singly linked list. Okay, now if I execute this code, right now the values that we have in the singly linked list are 10, 20, 30, right? So if I run this, reverse singly linked list should contain 30, 20 and 10. So if I run, I'm getting I have used constant here. I can't update the constant, right? So let me just make it to let and let me rerun the code. Okay, you see the output that I have got is 30, 20 and 10. If at all if you want to validate, you can add few more values. Even single linked list is going to allow duplicates as well, right? So right now if I reverse this, 30, 30, 20 and 10 is what I am expecting. So if you see 30, 30, 20 and 10 is what I am getting. Let's just say I am having only two values. If I run this, 20 and 10 should be the output. 20 and 10 is what I have gotten. Let's just say I have only one value in the single linked list. If I have only one value, that itself is reversed, right? Even if I run here, 10 is what I should be seeing and 10 is what I have got on the console. Okay, so that is the effective way of reversing a singly linked list. Remember, the process is very important. Just remember the process, you will be able to write the implementation of it. Even after this, if you have any bit of doubt, you can still go to codingpile.org and you can see the visualization using the problem link that I have put in the description box, so that even if you have any tiny amount of doubt as well, you can get through by looking at the visualization in real time. Okay, so that's it for reversing of singly linked list. I'll see you in the next problem.